Welcome back to Season 2 of That's So Second Millennium, the Catholic Science podcast, where we look forward to the new synthesis in the new millennium between faith, philosophy, and science. This is episode 82 of That's So Second Millennium. We're continuing our interview with Society of Catholic Scientists board member Jonathan Lunine. Today, we're presenting the part of our interview where we discuss extraterrestrial life, primarily within the solar system, and in that context, our obligation to protect such life if it happens to be there, as we look for it. A challenge that, fortunately, people have already seen and have started to take measures to ensure extraterrestrial biosecurity. So with that, we'll continue with the interview.
Of course, we can't try to bring the subject up without talking at least a little bit about the question of life. And that was, from the perspective of someone as a practicing planetary scientist, and of course you're involved in the sort of scoping. I mean, planetary science, as I understand it, has a very formal sort of decadal, this is what we want to study in the next decade. We should, the funding agencies should target these areas. Could you talk just for a moment about that?
Sure. So the way I typically get asked this question is, do you believe there's life beyond the Earth? Or do you believe in aliens? Something like that. Usually the word believe comes in there. And when it comes to a question like that, there either is or is not extraterrestrial life beyond the Earth. And let's say self-aware, intelligent extraterrestrial life. It's not a question of belief. It's a question of, being able to actually find it or detect it. Do I think it's plausible? I think it's plausible. I think that given the fact that planets are extremely common in the cosmos, it is plausible that at least microbial life exists in many places in the universe, and in particular in our galaxy of 200 billion stars, probably in many places. Life began on the Earth in the geologic record not too long after liquid water became stable, and the impact rates of fragments of planet formation, the leftovers of planet formation, were kind of swept up by the planet, so the impact rates went down. Life begins to show up in the geologic record pretty soon after that. But it takes billions of years for complex life, for multicellular, differentiated animal and plant life to show up in the geologic record. In fact, it's only in the last 10% of the history of the Earth that we see animals. And why is that? What took so long? Was the evolutionary process on the Earth based on our biochemistry unfavorable? Was the Earth's climate history unfavorable? Or are we precocious? Does it typically take 10 billion years for complex life to? If we could answer that question, we could begin to get a handle on what the frequency of advanced, even self-aware sentient life might be. And given the fact that we don't have any way of knowing that for any other body other than the Earth, we can't answer that question today. And I try to emphasize that, and it frustrates people immensely because they want a planetary scientist to tell them that there are Vulcans out there, absolutely, and I just can't do that. Now, one of the areas of my own research is to plan missions to so-called ocean worlds in our own solar system. These are moons that have oceans of liquid water beneath their surfaces, Europa, Enceladus, Titan, others, to find ways to look for microbial life. And the best case for that can be made at Saturn's moon Enceladus, which is the one with the plume of ice and water vapor pouring out of the South Pole. You can fly through the plume. Cassini did that multiple times, analyze it. With the right instruments, you might be able to detect the signposts of biology. So that would be microbial biology. And if those, if we can get there again, do those experiments, detect microbial life, the next step would be much more difficult to try to collect it and understand, what its biochemistry is. Is it like terrestrial life? Obviously based on water, but, is it a different set of amino acids? nucleic acid bases? Is it DNA and RNA, or is it something else? A lot of questions like that. That would tell us the range of chemical solutions to the problem of life forming. And, from a religious point of view, I have no problem with this. God created wonderful structures and self-organizing systems, and that includes life. And so the superabundance of God's creation surely can include other forms of life elsewhere. The question, of course, a different question arises if we were to find a intelligent, self-aware, conscious life form on another planet that we could communicate with, that effectively would have a soul. And then we get into the questions that, what if they're fallen or not fallen, questions that were wonderfully dealt with in detail by Marie George in her recent book, Christianity and Extraterrestrials, which, if anyone's interested in that, I certainly recommend reading. But from the point of view of, the likelihood of that kind of advanced life, because it took so long for life to become advanced and sentient and self-aware on our Earth. In fact, even though we're only halfway through the main sequence lifetime of the sun, our star, we're actually most of the way through the habitable period for the Earth, because as the sun ages, it gets brighter, becomes more luminous, and eventually, long before the sun becomes a red giant, it will drive all the water off of the Earth. So we might be 80 or 90% of the way through the habitable lifetime of our planet. And,
oh, wow, that close.
And that, then really, I think, raises a big question mark about how easy is it for life starting on another body to evolve to the point that we're at today.
Yeah. Yeah. It is all a question of odds. It comes down to there's an insanely large number of stars and therefore planets in the universe. We're pretty sure of that now, but
Yep, and I apologize for this pun, but as a planetary scientist, I don't want to be the wizard of odds. I want to actually go and, study other life forms, at least within our own solar system.
Yeah.
You're also... Sorry, go on.
I was just going to say, there's so little with which to cast the odds at this point.
Yes, that's right.
It's almost a pointless exercise.
You're also reminding me, Dr. Lunine, of one of the other talks at the Society of Catholic Scientists conference at Notre Dame recently, where one of the speakers talked about the man-made brain organoids that are being
organoids.
Right, and because they have the potential, or they're designed to be close to the qualities of human brains, and indeed, therefore, human minds. At some point, one has to ponder, when do our responsibilities towards such forms of life and such forms of human qualities, do they grow to the point where we owe a special sense of responsibility or a special viewpoint to them? And does that same kind of question arise in dealing with the prospect of finding, quote, intelligent, humanoid life on other planets? And what would be our responsibilities to them?
Yeah, well, first of all, let me say that I thought that our conference this year at Notre Dame was really an outstanding conference. We had great speakers. The Society of Catholic Scientists organizes a conference every year in a different venue, and I thought this was incredibly thought-provoking and stimulating. So thanks to all those speakers, if any of them are listening to this. The organoids talk shocked me. I did not know about this. It was followed about 2 months later by an issue of Science magazine in which this was discussed for neural tissue, and I think the ethical issues are deeply, deeply troubling to say. Yeah. With respect to your question specifically, I actually think there's a more immediate question that we have to ask, which is, as we explore the planets of our own solar system and their moons, and we look for life and we begin to investigate potentially habitable environments where life could exist, I think we have an ethical obligation to do everything we possibly can to not destroy those environments. It would be the greatest tragedy, for example, and I'm talking even about microbial life. It would be the greatest tragedy if we were to explore Enceladus in such a way that we inadvertently introduce bacterial microbes into this ocean, and they took over and wiped out the native microbes. It would not only rob us of the opportunity to study the native microbes and learn something about life that had an independent origin, but it's making God's creation less abundant, less diverse, and it's robbing that creation of something that was there that humankind basically took away. So the question of what's called planetary protection and not going and wiping out other ecosystems is a really profound one. We often think of this in the reverse sense that, well, if we bring a rock back from Mars, is it going to have superbugs that will destroy all of us? Yes, you have to worry about that, but the likelihood that a bug would be closely enough related to our biochemistry that it could have such an effect is really quite small. But we could introduce bugs from our own biosphere that could have a deleterious effect. So I think that's the immediate question, because we have the capability to explore within our own solar system these worlds, and we have the capability to contaminate them.
If you enjoyed this episode, or it made you think, come on over to That's So Second Millennium's Facebook page and leave a comment or ask a question. We'd love to hear from you.